19. And as you see, it will be a brief chapter. You are not responsible for most of the contents. Just I will be describing extrusion, injection molding, and blow molding. Later, I will briefly talk about some design considerations and economics. Then we will be done with chapter 19. And as you see, obviously, this one is about just plastics. And the process I'm going to discuss all about plastics manufacturing, some kind of tubes, pipes, and other shapes. We have various types of plastic operations, but the first three are highly important. So our main focus will be on such processes. And as you know, we have plastics all around. There are different parts, different type of complexities. They can all be manufactured with various operations. And the first one is extrusion process. And in the extrusion process, how we start with some pellets, granules, or powders. Pellets or granules are like small rectangular or cylindrical in shape type of raw materials. They are usually in the form of thermoplastics. And then later what we do, we place them. Let me describe this process on the sketch. We place all these granules, powders, or pellets into this hopper, and then we make use of such a screw. So this is highly important. In extrusion process, we make use of such a screw and a longer one, maybe more than 1 meter sometimes. And the screw, as you see, we have some specific parts. We have feed section, so we are feeding simply raw material. Then we are melting this raw material with the help of actually some heaters here. So we have special heaters here trying to increase the temperature of our raw material. And also the temperatures increase due to the friction between the particles and also the friction between the walls and the particles. So for melting, actually, we make use of friction and also the heaters. And later, in the third part of the screw, we have the pumping section. And as you see, this material is pumped into a kind of an die or a nozzle, you see. And before this die, we have a kind of a filter. This is a wire filter screen. With the help of it, actually, the impurities are not extruded, not deposited or moved to the right-hand side. They filter them out and have a clean liquid material. And once you have this part, then by applying this pressure continuously, we can extrude different shapes. And the shape of our extruded material obviously depends on this nozzle, depends on the opening at the tip of our die. And there are some other properties, but not that important right now. But these are the fundamentals of extrusion process. So the screws in summary have feed section, melting section, and pumping section. As we have seen, the filter screen is highly important. With the help of them, the unmelted or some dirties are actually filtered out, and the quality of the extruded material is improved. And another issue is actually the cooling stage. Once this actual material is extruded, you should have a kind of a uniform cooling with different means. Maybe you have a kind of a chamber there so that we'll be controlling the cooling rate, and the resulting piece will have better properties. And with the help of extrusion, you can have different shapes. As I said, it depends on the design of your die. You may even have pipe type shapes. It's up to you. And even you may have some just tins of materials, some films can be manufactured with the help of extrusion. In some cases, if the shape is a bit complicated, if you want to have tubes and pipes, as we have discussed in the extrusion of metals, you may use again some spider dies. And in order to increase maybe the strength of these extruded pipes, you may embed some wires, like in the case of actually hoses. They are all possible with the help of extrusion. It's an example of a spider die. We may even do co-extrusion, like in the case of metal extrusion. You may extrude several materials inside each other so that different properties will be obtained. You may produce some electrical wires and coat these electrical wires with plastics. You may produce extrude sheets or films, or even thinner ones, plastic films. They are all possible with the help of extrusion processes. Now I will briefly talk about injection molding. The equipment is somehow similar. Again, we start with powders, pellets, granules, and then by using sometimes piston or sometimes again screws, what we do, we melt these material and then feed it again into this time we don't have a simple die, but we have a bit more complicated die. As you see, the material is actually pumped into some cavities in the die, and then later, once the die is actually cooled down, we will have solid products, and this is highly useful. This injection molding is highly popular. We can produce various shapes, cups, containers, toys. For toys, it's a very popular type of process, and it's highly utilized for mass production. You can see different examples here. This is the molded part, and it was removed later. You need to do some extra operations, some cutting operations, so that you don't have this sprue part or extra materials. These are some injection molded products. So it's highly versatile. You can produce various shapes, and even in the same die, you may produce, let's say, 4 pieces at the same time. Since materials in the state of liquid, it can easily fill these cavities, and later, once this injection molding is over, you can take this part out, take this part out of your die and do some cutting operation and just left with these desired parts. This is another example using different types of dies, but the idea is the same. This is an example equipment, injection molding machine. As you see, it's quite longer, but the main process happens inside here. The rest is actually for preparing the material. The state is changed. It's changed into liquid around here, and it's pumped into this die, and we have this injection molding operation around here. And we have another operation called blow molding. For blow molding, we have 2 different types. The first type is extrusion blow molding, and the other one is injection blow molding. So what is the difference? I will show you now the sketch of it. This is extrusion blow molding. What is the difference? It starts with extrusion. You see, this is our extruder. It extrudes a kind of a pipe, and then later what we do, we cut it into a smaller part and squeeze it with the help of these dies, and then later we blow it. We apply air, we increase the volume of this material so that it's actually volume is increased, its shape will be deformed, and our material will take the shape of our die. And once this process is over, we can easily open our die set and do some maybe cutting operation and have the desired part. And for the injection, actually blow molding, this is the second type. We discussed the first one, extrusion blow molding. And in the injection blow molding, the rest is the same, but at the beginning, what we do, we make use of actual parison. This is called parison, and this is manufactured with the help of injection molding. But the rest is the same again. We start with this parison and then put it inside our chamber, apply some air, hot air usually, and we blow it and try to obtain such bottles. So with the help of these processes, we can easily manufacture plastic bottles. These are mainly used for the manufacturing of bottles. We may further have multi-layer blow molding, but the idea is the same. So if you put different materials inside each other and then blow them together, then you have multi-layer blow molding, and with the help of it, you may improve the insulation properties of some containers or packages. And these are the processes you are responsible. Now I will be briefly talking about some design issues and then discuss some economics behind plastic manufacturing, and we will be done with this chapter. The intermediate parts are not important. You're not responsible from the intermediate sections. So what are the main guidelines while you are designing some plastic dies and maybe tools? You should be always careful about some sharp corners. You shouldn't have sharp edges, corners, since it's quite difficult to obtain with extrusion or with blow molding or injection molding operation. It's better you have smooth corners, smooth edges. And another thing, you should be careful about the properties of the raw materials. Since these are plastics, thermoplastics, their strength are not too much. They have lower stiffness and strength compared to the metal parts. And the thicknesses of these, some specific regions are highly important. And in extrusion, we know that the cross section cannot be modified, so you should be aware of that. And you shouldn't change actually the cross section abruptly in such manufacturing, such plastic manufacturing operations. Is actually all I can say about the design. And for economics, they're obviously not expensive, and especially for simple equipment like toys, some maybe cookware, you may use some plastic manufacturing operations. There's a nice table showing the cost of actually these operations. For instance, if you look at blow molding, it has a medium cost for equipment and the tooling, but it's actually economic cost is quite high. So you should be careful about these properties and decide on the best type of plastic manufacturing process. And in the injection molding, the advantage is that you may have several cavities, and at a time you may produce many of the same parts, maybe even different parts can be produced at the same time. So this might be an advantage of injection molding. And that is actually all I can say about this chapter. Make sure that you go through the related questions about extrusion, injection molding, and blow molding operations.